So kinematic indeterminacy, that is degree of freedom. Degree of freedom is number of independent translation or rotation that exist in a structure. When we say independent translation or rotation, that means if we have a structure and that structure can move independently, any point of the structure can move independently without causing a displacement or rotation to the other members of the structure is known as independent movements or degree of freedom. In that is the freedom of that point of the structure. So let us see regarding the degree of freedom, we have to find out degree of freedom for three structures, mainly beams, frames and trusses. So in frames we have two types of frames. One is constrained frame and another one is free frame. Okay, now let us see one by one. So we are going to calculate the degree of freedom or kinematic indeterminacy. I am using the letter dk for representing degree of freedom. So dk of beam structures. Okay, so for a beam you should know we have different types of supports like hinged support, roller support and fixed support, and also one more support, that is sliding support. Okay, so these are the various supports that exist in a beam, but generally we will have only these four supports, and we will be having, there will be joints too. So let us see what are the degree of freedom for each support or joint. So degree of freedom for hinge support is 1. That is, in a beam we are neglecting the axial deformations and only rotation is allowed in a hinge structure. And by coming to the roller support, we have degree of freedom is 1. And for fixed support, it is, since it is fixed, there is no freedom. That support won't move in any translation or rotation or vertical motion. So the degree of freedom of the fixed support is 0. And now coming to the sliding support, it can move only to one direction. So the degree of freedom of the sliding support is 1. And for joints, we will have two movements, translation and rotation. So when we said joints, joints include the point at which moment changes abruptly, and it is also the points where two or more members joined. Okay, so it is point at which two or more members meet, or the point of a abrupt change in the moment will be termed as joint. So let us see some examples for kinematic indeterminacy. Same example. First example, we have a beam with varying cross section. So here the degree of freedom is, at support, fixed support we have 0, and there is a joint, that is here we have a 1 degree of freedom, 2 degree of freedom, and another fixed support 0. So the total degree of freedom or kinematic indeterminacy of this particular beam is 2. Now let us see another example. We have a structure with this. Here we have a joint. At fixed support we have 0 degree of freedom. At joint we have 2 degree of freedom, and at hinge support we have 1 degree of freedom. So total kinematic indeterminacy or degree of freedom is 2 plus 1, that is 3. Now let us see little more examples. Here we have 1, 2 and 3. So total degree of freedom is 1 plus 1 plus 1 is 3. And fourth we have, so I hope you understand how to calculate degree of freedom. 0, 1, 1. So total degree of freedom is 2. Here the degree of freedom is, here it is 1, here it is 1. So total 2. Okay. So this is how we calculate the kinematic indeterminacy or degree of freedom of beam structures. I hope it is clear. Now let us move to frames. Degree of freedom or kinematic indeterminacy of frames. So I told you initially that there are two types of frame. One is free frame, another one is constrained frame. So what is free frame? As the name indicates, one end of this frame will be free to move and other end is constrained. So one end is free and other end is constrained. Type of frames are known as free frame. So when we talk about frames, say for example, we have a frame, the spotter frame. One end of this frame, that is this points, they are constrained, right? They cannot be moved. And this end are free. They can move either in this direction or in this direction. So this end we can say it is free. So these type of frames are known as free frame. Let us see some more examples. For free frames we have, see, one is free, another end is constrained. So you will be wondering what will be the constrained frames. So let us see what is constrained frames. So these are some examples of free frames. Now coming to constrained frames. So constrained frames are the frames with both ends constraints. Both ends means, look at this frame. We have a top and bottom of this frame is constrained with a fixed support. So both ends are constrained. Or this kind of frames can be like this also. See, all the ends are constrained. So these type of frames are known as constrained frames. So while calculating the degree of freedom of this frame, we have equation regarding the calculation of degree of freedom, dk, which is equal to 3j minus m plus c. 3j minus m plus c for free frames, and for constrained frames we have a slight variation in this equation, that is 3j minus m plus c minus s. Okay, what is this m, c, j and s? Let's see. So j is nothing but number of joins. Number of joins are treated as J, and M is number of members. Number of members, and C is number of constraints. Instead of constraint, it will be easy to understand that it is the total external reaction forces. That is, for a fixed support, we have 3 constraints. For a hinged support, we have 2 constraints. For a roller support, we have 1 constraint. I think you got it. And for a sliding support, we have 2 constraints. So this is the constraints or number of reactions of a supports. So by knowing this C and M and J, we can calculate the degree of freedom for a free frame. Now let us see what is the difference between a free frame and a constrained frame while calculating the degree of freedom. There is another term called S. So what is this S? S is the number of lines of constraint or number of constrained lines, which means how many portion of the structure is constrained is indicated by S, or number of constrained lines. For example, in this figure, we have one line and second line. There are 2 lines which are constrained. So the number of constrained line is 2. In this figure, we have only one line is constrained. So that is S is equal to 1. Okay. Now let us see some examples for free frames and constrained frames. How to calculate the degree of freedom. Examples. Okay. So for a frame, first example, we have a roller end and a fixed end for the spotted frame. So we are going to calculate the degree of freedom. So with the equation, since this is a free frame, the equation for degree of freedom is dk is equal to 3j minus m plus c. So j is number of joints. So let us see how to calculate joints. We have 1, 2, 3 and 4. 4 joints are there. So j is equal to 4. M is equal to connecting members. They are 1, 2 and 3. So this is the number of members, that is 3. And number of constraints. For fixed support, we have 3 constraints. And for roller support, we have 1 constraint. So number of constraints are 4. So by applying these values into this equation, we will get 3 into 4 minus 3 plus 4, which is 12 minus 7 is equal to 5. So degree of freedom or number of independent displacement in this particular beam is 5. Okay. Now let us see another example. We have a roller sliding support at one end and a fixed support at other end. So this is, this portion is free to move. Therefore, this is a free frame. Therefore, the equation for degree of freedom is dk is equal to 3j minus m plus c. And j is 3. So 3 into 3 minus number of members are 2. And constraint is for fixed support 3 constraint and for roller support 2 constraint. So total number of constraint is 5. So 9 minus 7 is 2. 2 is the degree of freedom or kinematic indeterminacy. So this is the example for free frame. Now let us see some examples for constraint frames. Okay. So for constraint frames, I have an example. So this is a constraint frame. So let's see degree of freedom for this frame. Here we have j is equal to, let's count the j, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So j is 10 and number of members. That is also coming as 10 and number of constraints. For fixed support, we have 3 constraints. So we have 4 fixed support and 1 roller support. So 3 into 4, 12 plus 1, total 13 constraints are there. And S is the number of constraint lines. We have 1 and another 1. So 2. 2 constraint lines are there. So the equation is 3j minus m plus c minus s, which is equal to 3 into 10 minus 10 plus 13 minus 2. So the value is 30 minus 21 is 9. So degree of freedom of this structure is 9. Let us see another example. So this is a kinematic indeterminacy of a constraint frame. Here we have the equation dk is equal to 3j minus m plus c minus s, where j is a joint. We have 1, 2, 3, 4 joints. So 3 into 4 minus, and we have 3 members and the constraint 3 plus 3 plus 1, that is 7. And minus s is number of constraint lines, that is 1. So 12 minus 9, which is equal to 3. So 3 is the degree of freedom for this structure. Kinematic indeterminacy of trusses. So when a truss member is considered, a member of a truss is considered, it can undergo compression as well as elongation. And due to this compression and elongation, the joints of a truss can have two translation motion, one towards horizontal direction, other towards vertical direction. And a truss can have three types of joints, supports. They are hinge support, roller support, and a fixed support. Hinge support and a fixed support cannot have any kind of movement in any direction. So we can say these supports have no movements possible. In roller support, it can move into one direction, that is parallel to the roller, and a free joint, which is the point at which two or more members of the truss meet, can have two types of motions, that is, one towards horizontal and other towards vertical. When we talk about kinematic indeterminacy, we know it is a degree of freedom of a structure. So, how a structure can be it can be put into a table and format that is support and fixed support, which are not allowed to move, can have degree of freedom 0. For roller support, since it can move to one direction, the degree of freedom is 1. And for free joints, it can have 2 degrees of freedom since horizontal and vertical moments are possible. Okay. Now let us see some examples regarding this. First example, we are having this network have one joint and 3 supports. Suppose first support, it has 0 degree of freedom since it is a fixed support. Here also degree of freedom is 0. here degree of freedom is 0, but we have one joint which have 2 degrees of freedom, either horizontal or vertical. So here the degree of freedom is 2. The total kinematic indeterminacy or degree of freedom is 0 plus 0 plus 0 plus 2, which is equal to 2. Okay. Now coming to the next example. In this example, we have 4 supports. 3 of them are hinge support, at which degree of freedom is 0, and a roller support, which have a freedom of 1 degree. So the total degree of freedom of this is 1. Now coming to the third example. In this example, we have 3 supports. One hinge support with 0 degree of freedom, and another roller support with 1 degree of freedom each, and a free joint which can have 2 degrees of freedom. So the total degrees of freedom of this structure can be written as 2 plus 1 plus 1, that is 4. Now coming to the fourth example, we have 3 supports. The hinge support have 0 degree of freedom, roller support have 1 degree, another roller support have 1 degree, and we have lot of free joints. That is, here we have a free joint with 2 degree of freedom, another free joint, another free joints, and there are 5 free joints. So the total degree of freedom of this support is 2 into 5 plus 1 plus 1, which is equal to 12. So this is all about kinematic indeterminacy of process.